Thank you. This is a joint product with Luca Stella, who is in Berlin right now, and Lorenzo Vaiani, who is around in the room. He did most of the job, so if you have any question, just ask him. This is the outline of the presentation. The research question are data, descriptive statistics, analysis, and policy implication. The research question is very easy. We know from a vast literature that familiar, social, and economic background influence the level of the cognitive skills of children before they enter the school system. So when they are in at the very beginning, they are different, and we see inequalities in the level of skills and competencies of students. So the question we ask is, do the school system compensate for such differences or not? Can the school system reduce inequalities deriving mostly from each student's background, or the school system itself increases these inequalities, and to what extent? In order to answer this question, we focus on INVALSI data, and we created a data set that includes the INVALSI test scores of students attending grade 2 in school year 2012-2013, and we then follow their school careers through grade 5 and grade 8. So we have a sort of a picture of the skills, the cognitive skills of students in three different moments, in different times of their academic career. The initial data set we started with includes all of the data that INVALSI makes available for students in different years. As you can see, it's the bulk, the whole population, the whole cohort of students, about 500 students in each grade, and you see differences in the numbers of students taking the INVALSI test in the chosen school years, and these differences may depend on several factors. The first one, simply students who attended the test, who took the test in grade 2, might not be in class in grade 5 or grade 8. Some students may be, as a previous presentation noticed, might have failed a year, so they take the test a year or 2 years later. Some students might have left school, while some others could have reached the country, and so they were not in the test some years before, but they are in years later. Our data set includes a subsample of these population. We do have about 400,000 students who took the INVALSI test, and for which we have INVALSI test scores recorded for all the 3 grades in the school years that we analyze. We only consider students whose personal characteristics, meaning gender, own and parents' nationality, attendance with nursery and primary school, as well as background information, meaning parents' profession, ECSC, and so on, are available, because we do undertake some heterogeneity analysis of results, and we are particularly interested in these characteristics. So it's not the whole population, it's a subsample of the population represented by students whose characteristics are always available. There are differences between our sample and the initial population of students who took the INVALSI test in grade 2, because our data set misses some individuals, and the loss is actually not at random. In fact, we see that students worst performing and students with lower socioeconomic background tend not to be present in following years. It's quite normal. They might have left school, they might not be in class during tests, or maybe they might have failed a school year, and so they might not be there when the test is taken. in general, as we can see, economically and culturally disadvantaged students do not show up for the INVALSI test appointment in the following years. This is something we should consider when we come to our conclusion, because that means that we lose the worst part of the population to our analysis. We did something very descriptive at the very beginning. We produced a set of what we call transition matrices that describe the relative position of each student in the ranking of the INVALSI test results in 2nd, 5th, and 8th grade. The matrix you see over there is the matrix in the lines. You see the quintile of the distribution of tests and where each student was in a school year in grade 2, and in the column you see their position in grade 8. So students being on the diagonal of this matrix are students which remain in the same ranking, in the same position in their school career. This is quite interesting because simply descriptive information shows that there is quite strong persistence. And what we did was to transform these boring matrices into nice pictures. In the left side of the picture, you see the different quartiles of the distribution. The gray color represents the lowest part, the worst performing students, and the red one is the best performing students. As you can see, most of the horizontal strips go just straight. Those who were in grade 5, those who were in an excellent position in grade 2 tend to be in the same position in grade 8. And those who were in a very poor position in grade 2 tend to be in a very poor position in grade 8. The upper left part of the table shows the whole population that we have. You can already see some differences when we split the population in students in the north, students in the center, and students in the south. As you can see, the students in the south tend to be more represented in the upper quintile of the distribution in grade 2, but they are not there in grade 8, 6 years later. And the opposite, the amount of students who were in a very poor position in grade 2 tend to increase in grade 8. We did something similar considering individual and background characteristics of students. So we have Italian students and foreign students. You can easily see differences when they start, when they enter the school careers. Foreign students are overrepresented in the lower quintile of the distribution, and they're not there in the upper quintile of the distribution. The same happens with students with at least one parent with degree or with no parents with degree, students with a working class background or a high status parents, and ESC, which is something not very different. So from a very descriptive point of view, we see that fluxes transition from one cell of the distribution in grade 2 to an upper or lower cell of the distribution in grade 8 is quite rare compared to persistence, and even more rare or rarer in certain classes, in certain part of the population. Chances to radically improve or to worsen one relative position are quite low, and when considering subspecific part of the population, data show that disadvantaged population tend to start from lower level of lower position and lower chances to improve their position. This is very descriptive, so we try, this is very preliminary, we apologize for that, to make something less descriptive and more relevant from the causal point of view. We estimate an OLS regression model whose dependent variable is represented by the average of the individual result obtained in the VIII test score on math and language in grade 8 when they end up their final stage of our data set, and the main independent variable is represented by the same result, the average of math and language in grade 2. So we try to explain the result they obtain in grade 8 as a function of what they obtain in grade 2. Moreover, we control for a set of individual characteristics, and we also introduce school fixed effect for grade 2. This is, in a few words, the equation we estimate. Y is the INVALSI test score in grade 8, X is the INVALSI test score in grade 2, M is the matrix of individual and background covariates, and S is a dummy variable indicating the school attended in grade 2, with epsilon being the error term. Main results, we estimate this equation both for quintiles, column 1 to 3, and for the absolute value of the INVALSI test. Results are pretty coherent and show that the school achievement in grade 2 is a strong predictor of school achievement in grade 8. The three different columns introduce different covariates and control for the school level. So we can force a little bit the interpretation. Results suggest that Italian schools have quite a lot of difficulties in compensating the cognitive differences in knowledge experienced by students at the beginning of their school career when they enter the education system. As a robustness test for our interpretation, we also test the same equation using the INVALSI test score in grade 5 as the main independent variable. As you can easily see, results are strongly coherent with our main results. And we also use results in grade 5 as the dependent variable of our equation, explaining results in grade 5 with results that students obtain in grade 2. Nothing really relevant changes in these different equations. We also try to, moving from one quintiles to the following quintiles might be quite a strong effort for students, so we decided to test smaller movements, a higher probability to move in an upper class, and we introduced column 4 to 6, the size of the distribution, and as you can see, results are always there and strongly coherent. So a change, our results are in generally robust to a change in the outcome variables. We use quartile, quintiles, deciles, and absolute values, and to the introduction of the two different subperiods of observation, grade 2 to grade 5 and grade 5 to grade 8. We also tested some heterogeneity analysis. We tested the same, we estimated the same equation for some subpopulation, males and females, immigrants and natives, medium to low educated students versus high educated, parents with high education, parental education, attendance of kindergartens, and results tend to show higher persistence for males, for natives, for highly educated parents, for parents in higher occupation, and for students who attended nursery schools and gardens. And that's it. Our results have some possible policy implications. These are very preliminary results. Of course, something more could be done. First of all, of course, we need schools should need to pay more attention to students with cognitive differences at the very beginning of their school's careers, because differences who are there in grade 2 tend to persist over time, And this need to intervene very early might signal that some intervention before entering the school system could be necessary at the level of kindergarten, nursery, and pre-primary schools. And this is pretty it. Thank you so much.
Thank you.